last video, we saw how a debate ensued between people who think of thought through the lens of language and others who are more impressed by the imagistic aspects of thought. And both of these are very abstract questions, aren't they? It's not immediately clear how you would go about resolving such a dispute. That's why I say we're always on slightly shaky ground. But I thought the Shepard and Metzler experiments using mental rotation were particularly clever. They were able to show that there was an irreducibly spatial component involved in reasoning about these shapes. So I want to continue with that theme of how we can ask questions that can shed light on such difficult topics. It turns out that the manner in which you represent something greatly influences what you can do with it. To come back to the maps we had in the first example, some stuff was just immediately apparent when you looked at the map. You could immediately see that the airport was to the north of Salt Lake City, for example. Other stuff was there, but you had to work harder for it. So you could figure out what the distance between two towns was, but you had to do some work, take a piece of string, lay it down, find the length of the piece of string, measure it, use a scale to convert it, and so on. So it was there, but it took a bit of work to get to. So the manner in which something is represented will change or alter or influence what you can do with that. And this opens the way for us to construct experiments or experimental questions that can contribute to this debate. Now, take, for example, the question of numbers. You're familiar with numbers, you use numbers and you can do sums. Down at the bottom there, I've shown you two numbers, and on the left, they're in the familiar Arabic notation, using the digits that you're quite familiar with, and you know how to add these two numbers. You've learned how to stack them up and how to do your sums and all the place addition and carries and all that. You know how to do that. On the right-hand side are the same two numbers, but they're represented this time using a different system. This is the system that was in use in ancient Rome 2,000 years ago. And they're the same numbers, I'll guarantee you that, 3,456 and 284. How would you do addition using these? You'd need a different system, wouldn't you? It wouldn't be as easy as using the base 10 Arabic numeral system. In fact, it turns out it's desperately difficult to do addition and multiplication, division and subtraction using Roman numerals. They're the same numbers, but they don't support this kind of operation. So the way that something is represented influences what you can do with it. Now, I hope you are familiar with the idea of a phone book. They're very much out of fashion now, but all my life up until quite recently, every year you got a great big stonking book delivered to the door, and in there was a list of all the phone numbers, these are the landline numbers, of people who lived in your city. So if we had such a book, I'm hoping you're familiar with the idea, if I give you that phone book, it contains or represents a lot of information about people and numbers. If I give you the phone book and ask you, what's the phone number of Mr. Thelonious Winterbottom, it's a fairly easy question to answer. You open the book, they're alphabetically ordered, you go to W, and then you quickly home in and find Thelonious Winterbottom. An operation that shouldn't take more than 20 seconds. I could give you the same phone book and ask you, who owns the number 282-4758? And now you're a bit stumped. And this is one of the shortcomings of the big old phone book compared with a computer database, which could answer this question just as quickly. But if I have represented my information in one way as it's found in a phone book, this is a desperately hard question to answer. The information is in there, but the only way for me to answer the question is to start at the first phone number and go through every phone number in the book looking for this number. That would take a desperately long period of time, will be very subject to errors and mistakes. And basically, that's not how phone books are supposed to work. The information is in there. In one sense, the phone book is nothing more than an association of a name with a number, but the way it's represented hugely influences what you can do with it. A bit like it's easy to do addition using your numerals, very difficult to do it using Roman numerals. Here's another question. Name 3 bands who are a bit like the Beatles. So you sit there, I don't know what you're going to come up with. I'm just going to go, I don't know, Rolling Stones, Beach Boys, Velvet Underground. I don't know, they're all bands from the 60s. You may have answered this question differently. You might choose based on musical style, you might choose based on fame, record sales, your preferences. I have no idea. But you can answer the question. It's not a hard question to answer. You can just kind of do that. So this is going to tell us something about what the structure of your knowledge of bands is like, musical bands. Now, contrast this with this one. Name 3 bands where the 4th letter in their name is U. It's not an easy question to address, is it? I don't even know where to start. I can think of a band and then check to see is the 4th letter of their name U. But then if it's not, I don't know which band to choose. I'm just going to have to do them one after another. It's going to take me forever to answer this question. Just like doing arithmetic Roman numerals or looking up the name given the number in the phone book. This, you do know this. That is to say, if you think of the band and you happen to meet a match on the letter, then you knew enough to be able to answer the question. It's just the question is asked in a way that is not well aligned with the things you know about bands. Whereas asking you which band resembles the Beatles was much easier, showing that spelling is not important when it comes to bands, but genre and decade and taste are. No big surprises there. We're going to finish with one more of these, and this is one that would be used in experiments in cognitive science to investigate the nature of phonological representation in brains or minds. Name 3 words that rhyme with flap. Okay, I'm going to go. Slap, clap, trap. That was easy. It's a ridiculously easy one to answer. What does that show you? It shows you that whatever it is, whatever way your knowledge about language is organized, it supports rhyme. Rhyme is relevant to words and your knowledge of words in a way that, for example, decade and taste are relevant to bands, but spelling isn't. Rhyme is relevant because this is a really easy question to answer. So in each case, we've seen that some challenges were harder than others. The first challenge concerned the phone book. The manner in which the knowledge is represented in the phone book hugely affects what you can do with it. The grand challenges 3, 4, and 5 were about 3 and 4 were about bands, and 5 is about rhymes. And I suspect that they show you how we can ask questions in this domain in order to uncover some structural aspects of the organization of knowledge. So that's very much in the spirit of the experiments we saw last time from Shepard and Metzler, but looking at other domains of knowledge.